Hi everyone, I'm going to show you guys how to do this question. So it's a question with both projectile motion and collision. So I'll just summarize the question what they've given. So a cranberry falls from A, hits the plate B and bounces off over the barrier C, and it should land in the container. So using all this information, using all the lengths they've given, we need to find H and D. We need to find the values. So this question is a bit hard, but we could do it. So if you guys have any doubts, please drop a comment. I'll help you guys out. So let's draw a diagram. Now this section I'm doing is for our collision part. So it falls from A, which is at a height of 3.5 feet, to B. So this is B. So when it falls onto B, it hits B at an angle, right? At an angle alpha to the line, and it will bounce off to an angle of beta. And this is your perpendicular line. So if this is alpha, this is alpha, right? And using the alternate angle theorem, if this is alpha, so these two are corresponding and this is alternating, so this is alpha. And they've also given 5, 4, 3 at the diagram, so using that you can I'll write with another color now. 5, 4, 3. So tan alpha equals 4 over 3, right? We found alpha straight away, but we need to find beta. So to find that, so let's first find the vertical speed at which it hits B. So v squared equals u squared plus 2as. And since they've given the distance in terms of feet, we need the acceleration in terms of feet. Acceleration in terms of feet is 32.2 feet per second squared. So using that, v squared equals 0 squared plus 2 into 32.2 into 3.5. This will give you 15.01332741. I'll just round it off to 15.01 feet per second. So that's the velocity, the vertical velocity at B. So now, using the coefficient of restitution, which they've given as 0.8, E is greater than or equal to 0.8. So you should know the coefficient of restitution equals to, so you should always take the speeds for coefficient of restitution. You take the speeds that are in the axis of collision. So the axis of collision in this case is the perpendicular line I drew previously, right? This is the axis of collision. So it's going to be a final velocity. Since it's just one particle, it's just one speed. Final velocity over your initial velocity, right? And so we'll need to resolve the speeds onto this axis. Okay? So it's going to be 0.8 equals to, final is going to be, so I'll call this as VB and this as VA. So it's VB sine beta over the initial, which is VA sine alpha, right? This is one equation, and the other equation you can take is, you can focus on this axis and you can resolve the velocities onto that axis too, right? So coefficient of restitution won't affect this axis because that's not the axis of collision, right? This is your axis of collision. So you can write VB cos beta equals to VA cos alpha, right? VB cos beta equals to VA cos alpha. So you can write VB cos. So what I'm going to do is this. write this as the second equation. So you can write 0.8 VA sine alpha equals to VB sine beta. Take it as your third. So you can divide the third equation by the second, right? So you can write sine beta over cos beta. You can see VB will cancel off, that's why I didn't write it. So it just cancels off, equals to 0.8 VA sine alpha over VB cos alpha. VA cos alpha. So VA cancels off. So now we have tan beta equals to 0.8 tan alpha. So tan beta is going to be 0.8 into 4 over 3, right? Giving you tan beta is 16 over 15. And to find the angle beta, it's going to be 46.8476. This is your angle beta. Now let's focus on our projectile motion section. So I'll write in blue. So this is your particle. Now when it bounces off at an angle of beta. But we need the angle between the velocity and the horizontal. So I'll name it as theta because that's the angle. Theta is the angle you need for projectile motion, not beta. So this was alpha. So you could find x first, right? I can label that angle as x. You find x and you can subtract b. So you can do beta minus x equals theta, right? And to find x, it's x equals 90 minus alpha, right? So x equals 90 minus tan inverse 4 over 3. So this angle is 36.8698975. Now to find theta, you have to write beta minus x. So beta was 8476 minus 36.8698975. So that will give you 9.9777. So you can write it as 9.98 degrees. So this is the angle for your projectile motion. Now using this and using the velocity, we can find the distance for h and d. So we found the angle. Now let's find the velocity, VB. The velocity I labeled VB. So VB equals to, you can use the second equation, right? VB cos beta equals to VA cos alpha. So VB equals to VA, which was 15.01 into cos alpha which is 53.1301 over cos beta, right? So beta is 46.8476. So using that, you can find B. So the velocity of VB is 13.16779. I'll leave it as 13.1678 feet per second. So this is the speed the cranberry bounces off plate B. That's your speed at which it bounces off plate B. So now what you can do is, let's draw another diagram. Now we can focus on projectile motion. I'll write it in yellow. It's not hard to see, right? Yellow, yeah. So if I draw the particle like that, leaving at 13.1678 at an angle of 9.98. Okay. And I'll take the angle over here. So we previously had 5, 4, 3, right? We had 5, 4, 3, 5, 4, 3. I'll take it as gamma. Because we'll have to find H and D now, right? So if you look carefully in the diagram, you can see this is your highest point, right? That is your highest point, as it says in the question that it bounces over the barrier. So, and according to your diagram, you can see it perfectly goes around C. So C would be your maximum point. But let's see. So what you can do is, if you draw a straight line from point B like this, you can find this distance in terms of D, right? And you can find this distance in terms of H and D, because now this distance would be, using 543, you could find the distance, the horizontal and vertical distance, right? So I can write down horizontal distance in terms of D. I think this color is hard for you guys to see, right? Let me just write it in purple. So it's the angle we have there, so we could say this distance is D. Not precise, but you can understand, right? So your horizontal distance would be D cos gamma, right? So it's D, and cos gamma is gonna be into 4 over 5, adjacent side over hypotenuse. And your vertical distance is gonna be, so as I showed you in the diagram, this is your vertical distance, right? So it's gonna be H minus this D sine gamma, right? So H, so if this is gamma and that's D, this distance is D, so H minus D sine gamma gives you, we'll call it Y. Yeah. So you could write distance Y equals to H minus D sine gamma. So sine gamma is 3 over 5, right? So 3 over 5 D. This is 4 over 5 D. So now let's consider a horizontal distance. So for projectile motion, how do you find this horizontal distance? So this, I'm sorry, not the one I just circled. I'll call it as X dash. So X dash is your horizontal. So how do you find that? So when it comes to projectile motion, so in projectile motion, your horizontal distance has no acceleration, but your vertical distance has your vertical has acceleration, right? So x dash equals to 4/5d, which we just found, and you can write, s equals ut along the horizontal, so it's gonna be s equals to, so s is x dash, alright? So it's x dash equals to the speed 13.1678 cos 9.98 t, right? So it's 4/5d equals to 12.9685 t. So t equals 0.0616877 t. And now let's consider the vertical. So we know v equals u plus at, right? So now it's the vertical, and you should know in projectile motion, so I told you guys that this is our maximum point, right? It just jumps over the barrier, and according to your diagram, you can see after point C, it starts coming down, right? So meaning point C is your highest point. So at the highest point, vertical velocity is 0. So then you'll have vertical velocity 0 equals to 13.1678 sine 9.98, where you have to resolve it now. Now previously we resolved it onto this direction, now we are resolving it onto the vertical direction. So 13.1678 sine 9.98, and since it's going up, as your your cranberry travels up, your acceleration is negative, right? If it goes down, it's positive. If it goes up, your acceleration is negative. Minus 32.2 t, right? So we can find t equals, use your calculator. So t equals 0.07087. So, and we previously found t equals 0.0616877d, right? So now you can find d. So d gives you 1.15, so it's 1.14886, so I round it off to 1.15 feet. Okay, and now to find h, what you can do is, let's consider the vertical, because h is our vertical, right? So I told you guys the vertical speed at c is 0. So using your initial, we can use v squared equals u squared plus 2as. So it's 0 squared equals to 13.1678 sine 9.98 squared minus 2 into 32.2. It's minus, as I told you previously, it's going up, into s. S is gonna be y, right? This. So I can write this case into y. So if I just simplify this a bit further, you'll have 5.207696 minus 64.4 y, which was square. Yeah, I can't remember. H minus, I think I wrote it down below. H minus 3/5d. Okay, so you can find h minus 3/5d equals to 0.08086. So you can find h equals to 0.08086 plus 3 over 5 into 1.14886, and giving you h equals 0.77018. So I'll leave the answer as h equals 0.770 feet. These are your answers. So your final answers are D equals 1.15 feet and h equals 0.770 feet. These are your two final answers. So if you guys have any doubts with this question, please drop a comment. I'll help you guys out. And if you guys like my teaching, leave a like and subscribe. Thank you so much. Have a great day.